This is magnetic field measurement for Apparatus 2, again for calibration and error analysis purposes. We will use the same magnetic field sensor as before, and we will start by measuring the background magnetic field. This should be the geomagnetic field. It concerns me a little bit that the geomagnetic field value here at a slightly different location in the lab is different from the one for the Apparatus 1. Here it'll turn out to be about 0.06 millitesla. I guess one upside is that the magnetic field we will be applying will be much larger than that. So the fact that geomagnetic field appears to be different shouldn't affect our overall result too much. So here the current markers are in 0.3 ampere increments. So I'm going to set the current to 0.9 ampere instead of 1 ampere. So with the current set at 0.9 ampere, we will measure the magnetic field again around the Lorentz tube. This will give you the worst case scenario variation in magnetic field, and later on we will remove the Lorentz tube so that we can measure the magnetic field in the center. So I will move the magnetic field sensor around the Lorentz tube to get a sense of the range of the magnetic field. And this data will be available in a comma-separated value file later. Take a note of the dataset title. This is dataset 2, and that's the same title that the comma-separated value file will use. Now I'm setting the current at 2.1 ampere, so 1.8, 2.1 ampere to get a value that's as close as I can get to 2 ampere while falling in one of those markers. So this is the magnetic field measurement around the Lorentz tube. I think the size of the G component of magnetic field is larger than before. There's a noticeable difference between the X component and the magnitude. Something to be aware of and be ready to correct for if necessary. Okay, let me turn the current to counterclockwise. And this ammeter indicates the direction of the current, so it'll go in the negative direction. I'll set the current to minus 0.9 ampere and measure the magnetic field again. With this direction of the current, the magnetic field points into the sensor, so the X component of magnetic field is negative, as with the Apparatus 1. Let me zoom in a little. And now let's measure the final value with the Lorentz tube, minus 2.1 ampere. So this is the magnetic field around the Lorentz tube. At the front of the tube, it should be roughly at the center of the coil. Okay, so that's it for the magnetic field measurement with the Lorentz tube in place. Now we will remove the Lorentz tube so that we can measure the magnetic field in the center of the Helmholtz coil arrangement. the measurement taken here will be useful to verify that when the Lorentz tube is disconnected, the electrical arrangement doesn't change too much. There are some readings where the sensor is at the same relative location, and they can be used to compare the two readings. Okay, let me measure the background reading first without any current applied. The power supply is on, but no current is applied. And as before, it gives me that concerning 0.06 millitesla measurement. Concerning because it's not the same geomagnetic field measured before. And we will apply the same amounts of current as before. First in the clockwise direction, in the amount of 0.9 ampere. And let me start from the front of Helmholtz coils. So in the center region, this is showing the uniformity of magnetic field near the center region. And this is showing the variation of magnetic field along the axis. I'll leave the sensor in the middle for the end of the data acquisition. So this is 0.9 ampere. Let's try 2.1 ampere. And we start from the front of the Helmholtz coils. This is the magnetic field in the center, showing the uniformity with a small change in position near the center. And this is the variation of magnetic field along the axis. So this field value should be used to calibrate. Make sure that when you calculate the strength of magnetic field using the value of the current, that you get the same value. And to the extent that you don't, you should introduce a calibration factor so that when you see different values of current, you can get to the correct or more correct value of the magnetic field. So this is in the counterclockwise direction. Magnetic field in the center, relatively uniform. And as before, with the counterclockwise direction of current, magnetic field points in minus x direction. That's what these values show. And we will end this measurement with current in the counterclockwise direction of the magnitude 2.1 ampere. So starting from the front, this is the value of the magnetic field in the middle region, showing relative uniformity. And this is the variation of magnetic field along the axis for error analysis purposes. So that's the direct measurement of the magnetic field magnitude, also for Apparatus 2. This will help you narrow down sources of error and uncertainty for overall experiment.